throughout the presentation, use the Q&A function at the bottom of your screen. Right now, there are 2 questions in queue, so if you see that at the bottom, that's where you need to go and type your questions in. All right. So Andrew, if you're ready, please take over, and I'll stop my video and I'll stop my my sound.
All right.
Proceed.
Thank you. Good morning, everybody. And thank you for inviting me to give a presentation today. We think it's probably an important issue that we need to address, or at least be aware of. And it focuses on conservation practices, NRCS conservation practices that have been implemented over time, and that we are seeing some trade-offs that when you do implement these practices, they do have a great benefit, but there are sometimes some indirect effects that you need to be aware of. And so that's what I'm going to talk about today, and a little bit more about what those standards are. I'm sure you're pretty aware, but just want to go through those NRCS practices that they have developed standards for. These have been designed basically to avoid the loss, control the loss, or trap that phosphorus runoff. I'm going to focus mainly on phosphorus today because of the concern with fresh waters and water quality, drinking water treatment, and so that's where we're headed today. But they are designed to into those 3 different categories by NRCS. But we need to be aware that there are some trade-offs. They do work and they do have great benefits, and we must take this information I'm going to impart as something that's not a reason not to implement conservation practices at all. It's the exact opposite. It's the fact that you just need to be, one needs to be aware of some of the pros and cons that are at play here. And then I want to discuss a little bit about healthy strategies, for the future, and what can we do. It's easy enough to identify a problem. It's a little harder to address that problem. So we'll try and do that towards the end. So the conservation practices that we're looking at to avoid, and basically that is the source of the nutrient, the source of the phosphorus, the 4 R's that are in play. And usually this is done through the Conservation 590 nutrient management of mineral and fertilizers and manures. Spreading the right amount in the right place at the right time, and in the right method. A lot of litter in the Bay Area, as well as where I am in Northwest Arkansas, is spread on pastures and it's surface applied. There is a nutrient management plan in place to look at the rates of the application. But anyway, the mainly is looking at those 4 R's and implementing those as a common sense practices. We have started analyzing the manure to know how much phosphorus, nitrogen, potassium is in it, so that it can be used as a fertilizer. But it's important to know, the nutrient content of that manure, so that you're not over applying nitrogen or phosphorus or one or the other. So I think that's been a great benefit here in Arkansas. It's no cost to the farmer to get that analysis done at the soil test lab. And this is somewhat we did in Pennsylvania, and it's ongoing. And we just did a small pilot demonstration of injection of manures that they can reduce phosphorus runoff by injection, and also reduce ammonia or nitrogen loss volatilization, because it's not being just broadcast as a slurry on the surface. So there's multiple benefits, again, the 4 R's. The next one looks at the controlling. How do you control the nutrients that are already in place? Conservation tillage reduces erosion, a major benefit to water quality over the years. And and it can reduce phosphorus loss to total phosphorus loss in runoff. Same with cover crops, protecting the soil surface during that vulnerable period of the farming cycle during the year, mainly in the winter. Keeping a cover crop on the surface can reduce phosphorus runoff, can reduce erosion, and in many cases increase infiltration. So there's benefits. And the other is looking at drainage. Tiles have been implemented widespread, mainly in a lot of in the Midwest, that has reduced surface runoff. It enables a farmer to cultivate on lands that he might have been too wet before. So it increases profitability, bottom line, money, income. But again, there are some downsides to tile drains, but they can reduce runoff and erosion from those sites if water is infiltrating. And then the last group of practices would be the trapping of phosphorus, wetlands. They can take up, they can retard the erosion of the particulate nutrients that have been running off, and some of them can even take up phosphorus in terms of the plant growth. That could be recycled if it's not removed from that wetland, but wetlands do play an important part, whether they are constructed or renovated or just enhanced original wetlands. And then the other one we visit a little bit is the vegetative buffers. They've been around for a long time, promoted in many states, some states even requiring them with certain practices and certain conditions. But they are very effective at reducing or trapping the particulates that are coming off a field. Some of them remove nitrogen as well. But there's another very important tool in the tool bag that we have to look at addressing nutrient runoff. And the conservation practices down here, you can see the ones associated with that practice. There are different variations, but vegetative buffers, riparian areas, all come under that umbrella. So what are some of the trade-offs? This is some work that we did in Oklahoma. It's a little, I'm not sure it's unfortunate or hindsight, but we did this work back in the early 90s. Others have done it since then and found similar results in certain conditions, certain areas. It's not universally the same, but generally we do find this to be the case. I know that, Ken Staver has done some of this type of work at the Y Institute in your area. But what we did here, we had the ability to look at 4 watersheds side by side. They were about a hectare in size, a couple of acres, and we were able to change the management on a couple of them. So we were having conventional tilled wheat, and this is in Reno in the southern plains, and they were left fallow in the winter. And there were 2 watersheds side by side again that we converted to no-till by having that crop or that cover spring wheat over the winter. And you can see pretty quickly there's a dramatic reduction. Sometimes it was as much as 95% of the erosion, and then particulate, and this was translated to be total nitrogen and phosphorus. So you can see some dramatic reductions and dramatic improvements that have been a great benefit to promoting the idea of no-till to ameliorate some of the water quality concerns. But in some of the other work that we were doing, even before that, looked at the chemistry of the soil and how it interacted with runoff. And one of the things that we were able to do in those days, this was back actually in the 80s, when the OSHA probably not quite as active as they are now, but we were able to do P32 runoff studies indoors in a rainfall simulator in a large building that was designed for something else, mainly a shop area, but had the luxury of being able to do this. And what we actually did was have this runoff, simulated runoff on soil. We packed into boxes. Other people have done this type of runoff work since then. We replaced that P32 at different layers in the soil up to the surface, and then rain on it and see how much we could measure in the runoff. The idea here is that the phosphorus in a soil, whether it's from manure fertilizer, but once it gets into runoff, say a soluble phosphorus, you can't tell really where it originated from. Some work's kind of working now with DNA, but generally you just can't really say where, what the source of that phosphorus was. Was it originally in the soil, or was it from manure, was it from fertilizer? But having P32, you could identify where that phosphorus came from. And so what we're able to show was that most of the phosphorus coming off in runoff was within this top inch, 2 centimeters of soil. And that really helped us define that this is an effective depth of interaction. And that really, if you're looking at runoff losses of phosphorus, you need to really manage what's at the surface and the surface inch, generally speaking. And it could go down another ½ inch to 2 inches, but generally speaking, phosphorus in the soil is more readily transported if it's in the surface. And so that leads us to the idea, well, does it come in leach as well? And we know with some, with no-till, as with cover crops, we do get more macropores, more earthworms in the soil. Soil health has improved, the aggregation has improved, it reduces runoff erosion, like I've mentioned. But there's also these wormholes, just an example, and all root channels. We actually put some lime on the surface of the soil and rained on it, and the lime actually moved down and coated these channels just to give us a visual idea of water moving through the soil. And you can see that they move quite deeply down the profile. This is about 2 feet. But what it shows is that under these conditions of improved organic and situations, that there is some enhanced movement of water through the profile, through these channels, through these root zones that you need to be, one needs to be aware of, which in the end could increase lateral or sort of vertical movement of water and any nutrients that might be there with it. And so that's the kind of the backdrop then to the other side of this story. By looking at runoff from those watersheds in El Reno again. This is a soluble phosphorus from the conventionally tilled, not much happening at all. It just pretty much is under conventional tillage, which was fallow in the winter. We do see these concentrations, these are mean annual averages, just bounce around a little bit because of year-to-year fluctuations in rainfall. What happened when we looked at the soluble phosphorus? It did go up. It went up from around 0.2, 0.25 up to 0.75 parts per million in the runoff. And so you need to be aware of the fact that this, without incorporating that fertilizer that was continued to be applied to these watersheds, that we did get this increase in soluble phosphorus. So what happened was that although total phosphorus decreased, soluble phosphorus increased. Means that there's a greater amount of that phosphorus that's running off in this situation was soluble. The same thing happened with nitrate moving down. This is a shallow aquifer about 10 feet below the surface. We did see some increased nitrate in that. So there is this evidence here of that increased infiltration, which was 30%, 33% reduced, a third of it meant that runoff was reduced, but that water's got to go somewhere, and it infiltrated and it took some nitrate with it. So this is one of the trade-offs that we need to be aware of. Cover crops, another very popular, common conservation practice for many operations. There are many cover crops out there that you're probably all aware of, different types, different situations, different farmer preferences, what they like and what they feel best matches their operation. And they do decrease runoff and erosion. We know that they're a great benefit. They also could increase the organic matter content of the soil if that material, that plant material is incorporated back into the soil. Some of the work we did in Fort Cobb, this is peanuts with and without a cover crop. With a wheat cover crop, you could see quite a dramatic reduction in runoff, erosion, similarly, and bottom one here, total phosphorus. But again, that soluble dissolved phosphorus became increased, and it came a greater percentage of what was coming off of the total phosphorus. So, you know, that was some background information to it's a benefit for cover crops, but it just, again, one needs to be aware that sometimes that increase in that concentration of, or at least that loss of dissolved phosphorus is sufficient to perhaps accelerate eutrophication of some sensitive waters. So why was this happening? We had a lady that came over from Finland, Marianne Beckman, Norway, sorry, and to look at, she did some work looking at this. What we were able to do was freeze thaw some soil boxes that had, and then rained on them, basically 8 times. So what you do is you freeze it in a large freezer, bring it out, rain on it after a day or so, and kept repeating this, putting it back. And then, and this was with this rye grass on the surface of the soil, at least growing on the soil, sorry. And you can see that the water soluble or the water extractable of that organic of that residue material, just by shaking it up without any soil, or just having the vegetation growing, cutting it, freezing it, thawing it, freezing it, you could see that that water extractable phosphorus became more easily washed out of that plant material. And so when we look at the runoff occurring, we see that translated into a dissolved phosphorus loss that was much greater than it was when that soil, that vegetation, and it was left unfrozen. Again, it's a not a reason to not implement conservation, to not implement cover crops. It's just a trade-off that one needs to be aware of in doing that and manage that accordingly, which I will get to in a little bit in the time. The other one that I mentioned here was tile drainage, and nutrient transport from tiles does present some challenges and solutions, but it does present some solutions that those fields would be at least become productive, which is very important. But there's a rapid throw of water into artificial drains that can be important for nitrogen and phosphorus transport. I mean, the idea of having a tile drain is to remove that water from the surface soil so that it is less, has a lower moisture content so that you can actually cultivate. So that's the idea. But by moving that water through the soil, there are some things one needs to watch out for. And mainly that is by enhancing that water movement, getting it out of the soil at a certain time of the year, mainly in the early spring when planting or some operation needs to take place on the soil. That rapid movement can bypass or move through the soil quickly enough that the soil doesn't have as great a propensity to bind that nutrient or take up that nitrogen or absorb that phosphorus. And so that's a process that occurs. And again, it's similar with some of the other things I was talking about. The loss of P may be small, but it can be enough to accelerate eutrophication of some, what I would call sensitive waters. Those waters might be have a long residence time of water in that lake, water body, reservoir, or stream, where they do become sensitive. Looking at some of the movement of phosphorus in tiles through tile drainage, there's been quite a bit of work done. Here we can see some work done in Indiana by Doug Smith, looking at on more of a very short time scale. You see that the rainfall occurs, and there's a fairly rapid movement response, as we know we would expect to surface runoff, but there's also this pretty quick response here to tile flow. So you see that the water, and this is where they're designed, does move quite quickly through the soil, and you get this hydrograph that is fairly responsive, similarly to surface runoff, to rainfall. Again, we did this work when I was doing my PhD. That's obviously a long time ago, but there is still some relevancy, I think, and some information which has been supported through Doug's and other Kevin King's work in Ohio, where you can see these peaks of discharge from a tile drain. And this was, again, over a few hours, so it's fairly intensive sampling. And this was done by hand in those days, not automatically, but you can see a couple of peaks of tile flow here, just a different rainfall passing through. But what we did find is dissolved phosphorus was flushed through fairly quickly prior to this peak of flow. And again, other people have seen this, but I think the important point is here that there is this transport of phosphorus, but it's like a lot of things. If you have to do some intensive sampling to get to the a complete picture rather than just part of the picture, because this is so quick here. If you weren't there to collect the water and analyze it as it was increasing, you would miss this flush where there is some phosphorus being transported in tiles. And so it's just important to be able to do this type of work and to do it in a rigorous manner that you can pick up these trends and this movement. So I think I would like to just kind of, maybe just a bit more now looking to the future. Just this idea, and this was partly stimulated by Don Flayton, who we worked with. I know Amy and others have worked with him a lot out of Winnipeg, where they have some similar issues of what we're dealing with here. But this idea that of treating conservation management like human health. Basically, this idea is there is no panacea. Even though you may hear it from some people, it's just not. There is no magic silver bullet either in healthcare or in conservation. But we're all aware of the benefits of over-the-counter medicines and whatever. They're plain, they're there to see. But the risks, are we as familiar with all of these different risks that one has with taking these? They're very plainly assumed, but I think a lot of people are not as familiar with the risks as they are with the benefits. And it's a similar transition and an idea of at least getting this message and making it these picture images, these to the audience, and I guess in this case, watershed managers, farmers, just to easier understanding of some of the things that we're trying to get that message across. And so the idea is this conservation management is very similar to treating human health management. First, you've got to do a triage. You've got to assess each site comprehensively. There's no point in trying to control, putting in a conservation practice like no-till to control, or a buffer to control erosion if there's no erosion coming off of that site. If it's not particular phosphorus, you've got to find out, understand that site visit to be able to at least start that process of what conservation practice may work best there. Then we get into the next phase of the diagnosis. Like I mentioned, is it particular, or is it soluble phosphorus loss? Is it the nutrients coming from actually running off the field, or are they already in the stream and they're masking that they're what we might call legacy that's already in the stream channel? You've got to diagnose the underlying issues that you're dealing with, and then prescribing a treatment. And it's this idea that you don't have to cut somebody open to find out what's wrong to prescribe what the healthcare would be. And it's similar with conservation practices. You understand the system, you understand the fields, and the fields as how they're connected to each other and the stream. And then you can appropriately select the best beneficial conservation practice and target it to the areas that are of greatest concern, that considers the overall health rather than just a piece of it. And then I think what's probably very important is getting more attention, is that once you put these practices in, you just can't walk away and go to do something else, assume that they're going to work. We need to look at them over a period of time, and maybe they don't work as planned in the beginning, but need to be aware of it. That's not a fault, that's not a problem, it's not the farmer's problem. They follow the best science available, they put the practice in. Sometimes they need to be adapted, and so that needs to be considered. So triaging, locating hotspots. Again, this is some work from Pennsylvania. This is what we call the FD36 watershed at Klingerstown in your area, really. There's this area where Bill Gaburik and others were putting this really intensive monitoring to just get background information on hydrology. Bill was a great hydrologist. And so what he was able to do is looking at runoff volume coming off of this slope. There was no plot boundaries to it. There was natural runoff being measured here. There were some piezometers to look at subsurface water, how high the water table was. They were all data logs, so you have a continuous measurement during the rainfall, natural rainfall events. And also runoff sensors, where there were just some actually a battery from a watch that was used to trigger whether the surface runoff occurred or not occurred at these little small points. It didn't tell you how much, but it told you where runoff was occurring and where it wasn't occurring. And so it was able to, through this intensive monitoring of a site, able to look at what we call as critical source area, or this show that in many cases we were getting some saturation runoff that rather than infiltration excess, it was saturation excess, that the areas down here you can see are wetter. They tended to be a generator of runoff water. And so they came up with this idea, which you're probably aware of, it's underlying some of the 590 standards now, of what you really have to be aware of is that you have to have a high source and a high transport. It's no, having a high source or a large amount of phosphorus, say, in a field, or it's been applied to a field that is not connected to a stream. Maybe it's up here in this area, not connected, distant, quite distant from a field. It is not a problem, much of a problem as having a field that has some phosphorus in it that's right next to the stream. And so it's this idea that where you have this connection where you have this overlap of a high source and a high transport. These are what we would call critical source areas. And in this case, it was a clayey soil that was in this area here that would have a less infiltration, greater runoff potential. And there were some, a higher phosphorus concentration there. And so these are the areas that we would want to manage more carefully. And the idea, the benefit of doing this work is that all the fields on a farm are not going to be the same. And you know that, we all know that. You can drive around looking at it, and it's obvious that they're all different. They all have their different properties in terms of hydrology, nutrient movement, and to a certain extent productivity. But what it led to was this idea that 80% of the phosphorus is coming from 20% of the watershed, of the land area. Other studies have found similar to this in Europe. They've also shown it with subsurface. It's not always the same 20% of the watershed in different watersheds. It could vary. In this case, the area up here on a higher ground did have some infiltration. The water would move down the slope and hit a plow pan or a fragile pan and resurface down near the creek. So again, it's a standard that has been used for targeting conservation, but also targeting practices that might, where management of nutrients may be more carefully done. The idea that you have certain amount of funds that it's you can't address the whole watershed. You can't put conservation to the whole watershed, but you could you can't put conservation practices across the whole watershed, but if you could identify that 20%, you have much better benefit of, or you have a much better idea, expectation of success if you can identify that 20% and put the conservation practices in those areas. So the diagnosis is just an example of some of you may be aware of back in the, starting in the 70s, the monitoring of the Maumee and Sandusky in Western Lake Erie by Pete Richards and David Baker in Heidelberg. But it's a good example of a diagnosing a problem. And they were able to do long-term monitoring of nutrients coming into the lake from these two watersheds. There was little animal agriculture in here, but what there was a concerted effort to implement conservation measures and nutrient management planning, soil testing to know how much fertilizer to apply, and reductions in amount applied of nutrients did go down in these watersheds. And what happened was these concentrations annual again over a year, over about 15, 20, 30 years, 40 years actually now. You can see that the total phosphorus is pretty steady. Again, you have these wet years, dry years, but they're averaging out. There's a decline, slight decline. But what was found was that that these measures that were put in place, there was a change, something happened around here, and then we started to get an increase in dissolved phosphorus. It wasn't total amount. Again, it's this idea that the amount of phosphorus coming off in runoff transitioned from being particulate to being dominated by dissolved, which is probably more algal available or has a quicker response in terms of eutrophication of a receiving water. Again, looking at what happened over that period a little bit more deeply, look at this. Helen Jarvie did some analysis of the data that Pete Richards and David Baker had collected. And you can see here, this is the tons per day of nutrients flowing into the lake. Followed a pretty good relationship here. The red are from 2002, 2012. The blues are earlier decade prior to that. When you look at dissolved phosphorus, these same values, these points then tended to spread apart a little bit, and you've got this different trend occurring. So there was something happened around 2002, sorry, beyond this, where there was a shift to more transport as dissolved phosphorus, which caused this uptick in eutrophication of the Lake Erie, which we're seeing to the current day. So the idea is then, but how do you prescribe the treatments? And what, in hindsight, what Doug Smith and others found was, and people at Heidelberg, that some of the algal activity was caused by the surface soil buildup of P, which we mentioned in earlier in no-till. By not incorporating it, it built upon the surface of the soil, and eventually that started to be a source of phosphorus in rainfall that occurred, that generated runoff from those soils. So that led this no-till over a long period of time, built up the P in the soil at the surface, at that 2-inch layer that I mentioned earlier, that started to be more susceptible to be to run off. There was more tile drain. There's been a huge delivery of tile drains into that area. Again, it has improved farm profitability, and sometimes in response to government mandates, maybe for biofuels, and to have more corn. There's a complex process of drivers here, but more tile drains. That means that those fields are drained. Now that water goes directly into a creek rather than bypassing that soil. And so what you see is, an increased flashiness. And in fact, what the drains are doing are increasing the critical source areas to an extent. And you've got to weigh, again, this is not saying that drains are bad. You just got to weigh that there are some things that one needs to be aware of, and that farmer needs to be aware of when implementing some of these measures. It does, by design, make these fields, the water that's draining into those tiles gets more readily into a stream, which means you have a critical inflection point where you have a large area of the water shed, either in no-till or tiles, that there's a certain point beyond which it's like a tipping bucket, that you have a huge area under that. Then it starts to be manifest in what we're seeing in Lake Erie. The other thing which they realized, which was very important, that there was a shift in climate, there was a shift in rainfall patterns, and prior to 2008, when we started to see that shift starting to occur, the spring rains were about 12% after that. It was about a third of the annual rainfall occurred in spring. So there's a shift in the rainfall pattern of when those intense rains occurred. And that is in a vulnerable, when the soils are often vulnerable, maybe they're fallow, they're not got the crop in that's protecting the surface and well established enough. So there's these other shifts that are totally unrelated to what the farmer's doing that were contributing. And I think that's a really important point, is that, we need to consider the day-to-day farming management decisions in terms of implementing practical, realistic measures that would be implemented on a farm. So providing long-term care, that's the last part of this kind of healthcare management. Make sure that it works. Oftentimes, you know, we might say the classic one was in Pennsylvania of nitrogen applications. Then we realized that by applying nitrogen in manure based on the nitrogen requirement, you're over applying phosphorus in many times, to 2 or 3 times more than what the plant would need. Doing that year after year, you build up the soil phosphorus. Around the time of hysteria, the awareness of what the phosphorus, how much you were applying and what was happening with that phosphorus in the soil that was running off, it basically changed overnight that idea of you need to apply phosphorus, manures based on nitrogen to based on phosphorus. And that was a really dramatic, caused a lot of concern, caused a lot of angst. It's not bad science, it's just that sometimes we need to be really aware that keep changing our minds as scientists and advisors, we're losing the credibility that we may have had in the first place if we'd had any. So it's using consistent metrics to measure these changes and the practices as to whether they're working or not. Adaptive management, if they're not working, we can't assume that they're going to work perfectly everywhere. We need to be aware and that we need to tweak some of these after the year 1, year 2. If we do need to tweak, if something doesn't work, we need to have a plan B. You need to really plan for the unexpected. Again, it's this idea that there's no panacea, no magic bullet, but we need to modify them as needed. And again, if the farmer has implemented these under the conservation standards and followed the guidelines that are well established in the NRCS standards for those conservation measures, then it's not their responsibility, it's not their fault. They've done the best they were available, but we do need to go back and look then at what else needs to be done. But again, this idea that we can't keep pushing back, trying to change what we did that perhaps we knew or we tended to ignore as being a trade-off, because you know, if the rates to work was for the washout. So where do we go from here? So in closing, I'd just like to suggest that targeted conservation practices, targeted to those critical source areas, targeted to the problem, targeted to the concern in that particular area, that particular watershed, that particular field, going from watershed to farm to field scales. There's no cure-all conservation practices. We have to get that message across that they have great benefits, but they don't cure everything, and there are some trade-offs. I think it's critical, and I know it's happening in your area, it's happening in more and more places now that we are doing more on-farm research, monitoring and demonstration. NRCS is supporting what they call a 201, 202 program, which is providing funds for farmers that turn around to a land grant or somebody with expertise to do the monitoring, the edge of field monitoring on their fields to find out what the practice is, how it's working. But the real benefit we found with some of these programs, by putting these traditional water measurement devices in place on rice in different settings, pastures, here this is a poultry operation. It does provide some demonstration, but I think the critical point which we all understand is extension is providing great benefits, but what we've learned is that empowering farmers, empower them to change, including them in what we call collective learning experience, that they are a huge benefit to getting that message across, to getting that message to their neighbors. This is one of the farmers we work with who was growing soybean rotation with corn. This is a local senator, poultry operator. This some of you may recognize. NRCS chief Jason, talking to one of a rice farmer down in the southern part of the state. But it's important. I think that's an important part of where we go forward, is engaging the farmers, taking them along on this, rather than doing the work, presenting to them at the end of the day. Include them in this process at the beginning of it, rather than at the end. They will. What we found is that they become invested, and you give them a little bit of data of what you found. They want more, and I think that's really encouraging. And so part of this then, just quickly here, just go through some more what we do. NRCS came to Sarah 17 in a group to look at, what are the trade-offs? So what I've been talking about is being accumulated into what we, an NRCS technical note. This is the group. It really looks at a diverse background of extension, land grants, ARS. We have Amy, who's in your area, and Ken are part of that. And we're coming, fairly close to our, at least getting that product in a shape to get out to review. And NRCS have been working with us. It was their idea in the first place. Dana Ashford, Lisa Duranak, and Jan Surface should get a lot of credit for promoting this and getting us stirred up to work together. And so the conservation practices that we talked about before, these control, avoid, and trap. And so avoiding some of what can be done, just quickly. Nutrient management of fertilizers for our management, better management to reduce the soil P buildup, including maybe the use of legumes in nitrogen. So you're maybe not needing to put the phosphorus on, so that it's a long used. We know that having legumes in part of the system provides that nitrogen. In manures for our management, again, it's this idea of avoiding soil buildup, surface application where possible, looking at if you do get some stratification at the surface, maybe incorporating that into the soil, but avoiding the times. There's Tony Buda, Zach Easton in your area are looking at using weather forecasting to help farmers better manage what the soil condition is and when not to apply manure. So those are some easy tools, new tools that farmers can use to help them schedule. Routinely evaluating for the stratification, again, and no-till. There's some vertical tillage or sliding incorporation of that surface layer, or getting equipment that can incorporate the fertilizer or manure into the soil in a no-till system. And so there's options that we're trying to look at, incorporating a cover crop, plowing it in, interseeding it into a cash crop. Need to be aware that this happens where I am, that the cover crop is often burnt in rice and then when the cash crop is planted. I think we need to be aware that if you terminate it through some agent herbicide, then that material is sitting on the surface and could leak nutrients in runoff if it occurred. So management of cover crops is really important. You can't just put them in and expect them to work. Subsurface drainage, need to assess whether that, reduce the runoff translates to a net benefit. Where you're enhancing bypass of water through the soil where that natural filtering occurs and limiting it. Vegetative buffers, they're great.
So Dr. Sharpley?
They do have a. Yep.
Yeah, you're running out of time. If you got a couple of slides you can run through real fast, that'd be all right, but you're about out of time.
All right. FGDs, that's what we're looking at, enhancing these buffers to retain the phosphorus. I'll just quickly go through these. I'm sorry about that. you get wound up in your own little world here. So overarching effects, conservation practice systems approach, looking at climate fluctuations, stacked practices, more robust, resilient ecosystems, protecting water sources before they become impacted, reducing the inputs and legacy peak, and that can benefits some of those, can delay some of those benefits. So thank you. Sorry for going over. And hopefully that, this will be available to you. So the bits I've skipped over will be a little clearer. So thank you.
So thank you, Dr. Sharpley. Do you have time to stay online and answer some of the questions that have been proposed to you in the question and answer box down below?
Sure. Yeah.
Yeah, so maybe that's the best place, folks, for you to interact with Dr. Sharpley is in the chat box, and he can answer some of those questions while we're getting ready for the next speaker. So don't forget, for those of you that are looking for your CEUs, to use the QR code. I see Jared has put it up on the screen, and make sure you use that so you can go and properly get logged in. If you are having trouble with that QR code and getting to your Examinall, be sure to reach out to Jared or Amy to get that resolved.